Hello and welcome back. In this video, we will be learning three different literals. The first one is integer, second one is floating, and then the third one is Boolean. Let's get started with our friend Scala REPL. And this time, if I check Scala version, I have newest version of Scala. I just installed that. So let's just get started with the REPL. Okay, there we are with the REPL. Now, like we did before in the previous video for uh, you know uh, character and string literals, we can do something similar for the integer literals as well. As usual, I can assign my integer is equal to 5 is an integer, so I can assign, and we can see the type is int, that's the integer, and integer range, that is from minus 2 to the power 31 to 2 to the power 31 minus 1, and the range for character is 0 to 2 to the power 16 minus 1. Short would be 2 to the power minus 15 to 2 to the power 15 minus 1, and the byte would be 2 to the power minus 7, sorry, minus 2 to the power 7 to 2 to the power 7 minus 1. Well, that's just for flavor. Maybe you can refer the book in order to have the precise value for the range, if you want to remember that, but it's not, if you remember, that's good. So anyway, so now that's 5 is an integer, and then we have we have negative integers as well. So I could do, well, my second integer is equal to minus 5. Let's do that. Okay. So we have type, we have negative value here, and then we have the identifier name. So integer, let's assign my big int. Okay. So integer's range is minus 2 to the power 31 to 2 to the power 31 minus 1. So if you try to go outside this range, then let's see what happens. It should give us some sort of invalid assignment or declaration or something like that. I'll just enter some random number here, 3, and then 1 2 3 4 5 6 7 8 9, just a random number, and then see what happens. You can see that integer number to large. Okay, so it's out of the range because it is from minus 2 to the power 31 to 2 to the power 31 minus 1, right? Okay, and there is one more way to actually define integer variable or assign integer to a identifier. That's using the hex notation. Okay, well, I'll just type 1 later here. Okay, again, not a good idea, but it works. You have a prefix 0 and the x. That's for the hex notation. Okay, and then you can have any number actually. You can do, let's say, what's the number for 15? What's the number for 15? You can see that 9 and then 10, 11, 12, 13, 14, 15, right? Okay, that's 15 exactly. Okay, that's the hex notation. So now if I give another something random here, ff, that seems to be 255, 3f, that's 4095, 4f's, 65535. Okay, so that's the hex notation. So that's how we kind of define or assign integer to a particular identifier in order to have a integer representation from mathematics, let's say. The next one is floating point. Okay, so floating point is basically a number with decimal. They also have range, and they follow basically the IEEE specification, IEEE 754 32-bit single point precision binary floating point number, or IEEE 754 bit double precision binary floating point number. So we can quickly Google and see what those are, the IEEE specification. But we'll take some example here and assign some integer value to an identifier val. Let's say b is equal to, I can say 1 e to the power minus 10f. Okay, that's the double number. Okay, well, I meant actually e here, exponent. Okay, e to the power minus 10, not d. D was a typo actually, sorry. So yeah, that's the floating point number actually. 1 to 1 to the power minus 10. Okay, and then we'll have one. Let's just type one decimal number here. Val c is equal to 4.5. Okay, that's 4.5. Now what happens if I say val d is equal to 45 e to the power minus 10? What is that number? E to the power, that's 4.5. Well, it just pushed that one, it made like 4.5 multiplied by 10, and then e to the power minus 10, and then it took that one, the 0 from 10, and then just reduced the negative power in the exponent. Okay, that's what it did. Okay, so instead of that, if I do this one, what is the number? That's 4.5. Okay, so 45 divided by actually 10 e to the power minus 1, that's actually 10, right? So that's how floating point numbers work. It's pretty straightforward. Okay, we just try to play with it to have just to have a little fun there. Very simple. But if you're doing a scientific calculation, it's very important to kind of remember what these notations are, and the best way to do. Why I try to actually be very flexible in terms of explanation, and is that it's always a very good idea to actually uh, after having basic mathematical ability, it's a very good idea to uh, use your version of the compiler or interpreter, whatever it is, and then play with it and see, because sometimes it's not always true for Scala, but for some other languages, different versions uh, might have different precision, and then same notation could give a different result, and that thing is not acceptable in a scientific computation where precision is demanded. And if the application is very critical, it might create a catastrophic result. So for that reason, it's very important to actually know what version of the compiler it is or interpreter it is, and then what all these notations mean, right? But for now, for us, for the introductory course, I think this is more than sufficient, because we're just trying to do common, uh, fairly simple mathematical, day-to-day mathematical um, representation here. Nothing fancy or nothing highly scientific type of computation. So that's why we are just fine. Okay, there's nothing to worry about. So the next one, the next literal that we would like to use is simple, very simple Boolean. It has either true or false, only two values. Okay, there can be anything in between. Sometimes this is also represented by the binary digit 1 for true and then 0 for false. Uh, while it looks very simple, the Boolean values are heavily used in programming in order to test the the conditions and then branch. Because if you see any professional program, it's very likely that there will be some sort of branching going on, and then that branching happens after checking certain conditions, and those conditions, mostly they result Boolean value. So let's just assign, let's just create one, val my Boolean is equal to false. Okay, okay, that's the false value. Okay, now if I say my Boolean, I get false, and then next one obviously is val, let's say my second Boolean is equal to true. Okay, those are just two values, right? And then what happens if I do true? That's a literal value, is equal to true, which is true. Okay, so that means I'm comparing it, and this means true is equal to true. This means assignment. Okay, so I'm assigning true to true, but I'm not telling what the first true, the one left to the equal sign is. I'm not telling whether it's a var or val. Okay, so that's why we get the error. But if I say val, let's see, since true is more like a reserved word, just double checking, that is true, it is a reserved word. And let's see if I can assign some value to this reserved word. Okay, Scala allows it, but for some other programming languages, it should have been an error. Okay, so now if I say true, that's interesting. It has a true value. Actually, it took it as a identifier because it's a reserved word. It's not a keyword. Okay, so that's good. So this is also another thing probably helpful to remember while programming. But it's not a very good idea to use reserved words, even if it allows us to do that. It's not a very good idea to actually use reserved word as an identifier. Now, if you see the expression val true is equal to true, it is already confusing. So not advised unless it is absolutely needed. If there is a critical condition, then only. Otherwise, I think it's a good idea to have some other type, of some other identifiers. It's always easy to find one because there are so many letters, and then that combination of all those letters, you can always find a new identifier. This should not be a problem. Okay, so I think we covered the the very useful and basic kind of literals. If needed, we'll add more videos in this section. Otherwise, we'll just move on to next chapter, which is actually a fun chapter, and that is classes and objects. If you're doing object-oriented programming, those are the key elements. Okay, until then, I would like to say goodbye.